Hi there, this is Miss Wesley, and I'm going to take you through the Geometry Review Day 2 packet, which comes from an old Regents exam. So we're going to start here with some multiple choice questions that are each worth 2 points, remember. So it says in the diagram below of triangle ADC, EB is parallel to DC, and they give us some values, but notice that they're also already labeled for us in the picture. The question says, what is the length of AC to the nearest tenth? So in these scenarios, I always try and like to let whatever I'm looking for, so in this scenario, AC, represent and be my X. So I'm going to let A to C be X. And likewise, if I look at the left-hand side of my triangle here, I can find that total length. 9 plus 5 will give me 14. So this is a scenario where it might be best to separate and redraw your triangles. So for instance, I know my big triangle has the left side is 14, the right side is X. Then I'm going to look and say, okay, well, I actually have this small triangle in the middle here. So if I draw that triangle out, my left side is 9, the right side is 9.2. So because these triangles have a parallel line running through them in the middle, that means they're proportional. So I'm going to set up a proportion here and then solve from there. So I'm going to take 14 over X equals 9 over 9.2. There's a lot of other ways you could have set this proportion up. You might have done 14 over 9 equals 14 over 9 equals X over 9.2. That's another scenario. But with this, what I have going on here, if I go ahead and cross multiply this, I'm going to end up with 9X equals 14 times 9.2 gives me 128.8. And again, I'm looking to get X by itself, so I'm going to divide both sides by 9. And that will leave me with an answer of 14.3. If I go back and check my work, it said find the value of AC. AC was X, so that means my correct answer here is choice 3. If you try this on your own and you got choice 1, all right, you are very, very close. What you did is you probably put X down here. So B to C is 5.1, and if you wanted to find A to C, you would take 5.1 plus your 9.2, and that would give you your answer of 14.3. Okay, moving on to our second question here. This says, in scalene triangle ABC, shown on the diagram below, measure of angle C is 90. Which equation is always true? So what's going on here, if you look at these choices, they're talking about sine and cosine, and they're talking about some different angles, A, B, and C. This is a question that's essentially evaluating your knowledge of cofunctions. And cofunctions talk about how sine is equal to cosine if, and that's like all in caps, that's the big word, if their angles add to 90 degrees. All right, so this is just one way they might test you on cofunctions. They've asked one cofunction question a year so far. So if we go through these answers, notice choice 1 has a sine and a sine. You're never going to have two of the same function next to each other. So likewise, cos and cos, wrong. We said over here we need sine and cosine to be equal if their angles add or sum to 90. So now I'm left with two choices, cos and sine, sine and cos. But if I take a look at choice 3 says sine of C. Well, C was already 90 degrees, so that means if I added A to it, this would be over 90, all right? So therefore, choice 4 is the correct answer. Because if you think about it, if C is 90, and a triangle has to add up to 90, A plus B is going to always equal 90. All right, so that was just a question seeing your knowledge on cofunctions. Likewise, question 13. This is a question on quadrilaterals. It says a quadrilateral ABCD has two diagonals drawn in. Which information is not sufficient to prove that this shape is a parallelogram? So the first thing I'm going to do is I'm going to simply sketch a parallelogram as best as I can. Not too bad. I'm also going to label it. So whatever corner you start in, make sure you follow that with a complete circle. And I'm also going to go ahead and draw in my diagonals because it said I had two diagonals, A to C and B to D. So which one is not sufficient to prove that these two are a parallelogram? Now, this question simply comes down to your knowledge of your parallelogram properties. That's all it is. So if you look at the first one, it says AC and BD bisect each other. Remember, bisect means to cut in half, and they certainly do that. That is true for all parallelograms. It's true for rhombuses, rectangles, and squares because of it. So this one is a property, so I'm going to cross choice 1 off. If I look at choice 2, AB is congruent to CD. Well, that's true. And BC is congruent to AD. And that is true. All right, that's another property. Opposite sides are congruent, so that's going to go away. Choice 3 says AB is congruent to CD, which we already proved here and here. But then it's also saying AB is parallel, so I can add in my arrows to represent that. And that is another true statement. One set parallel and one set being parallel and congruent. So one pair, congruent, and parallel. That's one that works. So that means we're left with choice 4. And if we look at the problem with choice 4 is first talking about A, B, and CD, but then it jumps and talks about B, C, and AD. And notice that the signs also change. So choice 2 was okay because it was congruent and congruent. Choice 3 was okay because even though it was congruent and parallel, we talked about the same sides each time. So choice 4 is the correct answer for this because that is not enough information to prove that they are a parallelogram. All right, moving on to question 14. Okay, question 14. It says the equation of a circle. All right, so right there you have to recognize we're talking about circles. Is x squared plus y squared plus 6y equals 7. What are the coordinates of the center and the length of the radius of our following circle? So in looking at this is not how we typically see circle equations. All right, so we need to turn this into our standard center radius form of a circle. So the first thing I'm going to do is I'm going to simply copy my equation, and I'm going to try and get my x's next to each other and the y's next to each other. Well, looking at this is the only term with x, so I'm going to leave it alone, x squared. Then my y's happen to already be next to each other, which is great. So y squared plus 6y. But now I need to add a box because I have to be able to factor this. So whatever I add to one side, I have to add to the other. All right, again, there's only one thing with x's, so I'm going to ignore the x's for right now and focus on the y's. In order to fill in this box, remember, you have to look at the number in front of the box, which in this scenario is 6. So to fill in the box, you take your number, you divide it by 2, which gives me 3. And then we have to square that value. So 3 squared will give us 9. So a 9 is going to go in both of these boxes. The reason that is helpful is because now I'm just going to bring down this x squared, because again, there's nothing else with x's. But if I focus on this quadratic, y squared plus 6y plus 9, I know that I could break that up into y plus 3 and y plus 3, because 3 plus 3 give me 6, and 3 times 3 give me 9. And rather than writing the same thing twice, we can simply write it in a set of parentheses, y plus 3, and I'm going to square it since I would need 2 of them. Now if I do the right-hand side, well, 7 plus 9 gives me 16. So this is now in the form that we want it. So the last thing we have to be able to do is we have to identify the center, and we have to be able to identify the radius. So our center comes from these values here. Now, since there's nothing next to the x, that means my center starts at 0, comma, remember, if this is a positive 3, when values come outside of parentheses, their signs have to change. So my center is at a 0, -3, and for the radius, you always focus on this last number, all right? This last number right here is currently standing for the radius squared. So I'm going to draw that off to the side so you guys can see it, r squared. So if 16 is r squared, that means our r is just 4. Therefore, looking at our choices, we need a center of 0, -3, so it's not this one or this one, and I need a radius to be 4, so we are left with choice 2. All right, so that was from Unit 7. If you're still understanding that, you can look back in your interactive notebook or in your notes. I'm going to move on to question 15. So we're going to scroll down here. 15 says, the triangles ABC and DEF are shown below. So a lot of you, what you first do, which is a great strategy, is you take this and you stack your letters. So A, B, C, followed by D, E, F. So if I kind of separate those out, that means that A and D go together, and B, E, and C and F go together. Next step, it says down below here that if AB is 9, so I'm going to label my picture, AB is 9, BC is 15, DE is 6, and EF is 10. And notice they're telling us that there's these pair of angles that are the same, so I'm going to mark up angle B matches with angle E. Which of the following statements are true? So, simply start by going through one choice after another. So if I look at this first one, CAB. So if I go over here to my letters, CAB. So notice I went last, first, middle. Is that the same as DEF, which goes first, second, third? That order is not the same, all right? You can see it just by looking at the shapes right there. So now let's go to my second choice. It says AB matches with FE. So let's check that. AB does not match with FE. So again, right there, we already found a second one that's wrong. The last two. Choice 3 says our triangles are similar. So remember, in order to be similar, the sides have to be in proportion with one another. So for instance, this 9 would have to match with this 6. So if I divide those, 9 divided by 6, and my calculator is going to simplify down to 3/2. Well, that's all great and dandy, but I got to check it with this side to see if it matches with this side. So 15 divided by 10. And what do you know? If I divide both of those by 5, I get 3/2. So the sides are in proportion. But SS isn't enough. Well, if I go back and look, I actually have SAS because of this angle in between. And SAS is one that does work. So I'm going to put a little dot next to this one because that's what my hunch is right now. If we check the last one, it says AB would match with FE. Well, AB, again, doesn't match with FE. Let's check the bottom to make sure. DE doesn't match with CB. And notice that they switched the order there on us. So choice 4 does not work. Oh, that meant to be my pen. Hold on. Choice 4 does not work, meaning we are left with an answer choice of choice 3.